Hello everyone. So today we are going to start MLflow. Currently I am in the documentation of the MLflow page and right now you can see overview of MLflow. So stepping into the world of machine learning is an exciting journey, but it often comes with complexities that can hinder innovation and experimentation. Okay. So MLflow is a solution to many of these issues in this dynamic landscape, offering tools and simplifying processes to streamline the ML lifecycle and foster collaboration among ML practitioners. How it helps us? See, whether you are an individual researcher, a member of a large team, or somewhere in between, MLflow provides a unified platform to navigate the intricate maze of model development, deployment, and management. MLflow aims to enable innovation in ML solution development by streamlining otherwise cumbersome logging, organization, and lineage concerns that are unique to model development. So this focus allows you to ensure that your ML projects are robust, transparent, ready for real-world challenges. So as we have discussed in the last few lectures, right, that MLflow can help you to monitor experiment tracking. These things can be done using MLflow, right? So that is what these people also have mentioned. It's a unified platform and we can navigate the intricate maze of model development, deployment, and management. So there are few components that we are going to discuss about MLflow, and as you can see, core components of MLflow. The first component is tracking. So MLflow tracking provides both an API and UI dedicated to the logging of parameters, code versions, metrics, and artifacts during the ML process. I think you guys can recall same I did using DVC, right? Now the same we can do using MLflow, and on that video also I have told you that those stuffs generally we do using MLflow instead of DVC because MLflow is more widely used in the industry. So again, it's dedicated to logging of parameters, code versions, metrics, and artifacts during the ML process. This centralized repository captures details such as parameters, metrics, artifacts, data, and environment configurations, giving teams insights into their model evolution over time. Okay, I will show in the practical part, then you will better understand these lines. Okay, but let me discuss these components first. Next is your model registry. So what is this model registry? It's a systematic approach to model management. The model registry assists in handling different versions of models, discerning their current state and ensuring smooth productionization. It offers a centralized model store, APIs, and UI to collaboratively manage an MLflow model full lifecycle. It includes model lineage, model versioning, model aliasing, model tagging, annotations. So model registry simple means that you can save the model, okay, and so that you can reproduce the same output whenever you required. Okay, and you can do model lineage, model versioning, aliasing, tagging, annotations. This all you can do using MLflow. That we will see in the practical part anyways. The next is they have provided MLflow deployments for LLMs. So even you can do LLM deployment using MLflow. Then you can do evaluation, reason in-depth model analysis. This set of tools facilitates object model comparison, be it in a traditional ML algorithm or cutting edge LLM. So you can, if you want to do any model comparison also, that you can do using MLflow. There's a prompt engineering UI, there are some recipes, there are some projects. Okay, so what is MLflow projects? MLflow projects standardize the packaging of ML code and workflows and artifacts akin to an executable. So project is like it will have everything, your ML code, your complete pipeline or the workflow and the artifacts that is it is generating while running the whole pipeline. This all comes under one project. That's what we call projects in MLflow. Okay, so we will implement one by one so that you will get a better understanding on this, like what does it mean, how do we use it and all. Okay, and again, why to use MLflow? Again, same thing I have explained to you in the very first video of this course, but yeah, they have mentioned also here why to use MLflow. You can do experiment management, you can do reproducibility, you can get a consistency in your deployment, you can manage your model better, Okay, it's a library diagnosticism. What does it mean? It supports all kind of libraries. Even if you have a TensorFlow model, if you have any scikit-learn model, so it supports everything. So it's really agnostic in terms of the libraries that we use to build any kind of ML solutions. Okay. Okay, so this is a like who uses MLflow. So these guys have showed the ML engineers, business stakeholders, data scientists, data governance officer. These people generally use this MLflow, and so these things are there. So now we will start the practical part. There I will show you a few of the things. So let's go to the notebook and then we'll see what we do. First of all, guys, as you can see, this is a MLflow folder. Okay, so here I have a folder called MLflow tracking basic, and inside that I have a this file called ML without MLflow. So let me first toggle the word wrap. Yes. So this is the code that we have in our hand, right? I have imported the libraries. I have called sklearn. I have called random forest. I have called some metrics that we calculate the metrics like mean, absolute error, R2 score, okay, and all. Okay. So first of all, I will show you a very basic code of a ML model. We'll build some ML model without using any MLflow components here. Okay. First, okay. So this all, I hope you guys know how to build any basic ML workflow, right? So this is the libraries that I've imported here. After that, as you can see, this is the dataset link. It's a dataset that is there in the GitHub, the student performance CSV dataset. Okay, if I just copy this link and if I show you the dataset, let's show the dataset now. So this is the data. It has gender, it has race, ethnicity, parental level of education, lunch, test preparation course, math score, reading score, writing score. This kind of data we have in our scenario. Okay. Now if I come back to the code again, I am reading this data using this URL. Then I am printing a header of it. I am dropping the nan values. Then I am doing some label encoding on the categorical variables in the dataset. Then I'm dropping the target column. I'm setting up the target column. Then I'm splitting the data. Then I'm scaling it using standard scaler. I'm doing fit transform on the training data. I'm doing transform on the testing data. And now this is the random forest regression where I'm calling the random forest model with these very basic parameters, and then I'm fitting the model. I'm doing some prediction, then I'm calculating the error as well as I'm calculating the accuracy of the model. And if I run this code, see, I have activated one environment already. In your case, you can create a virtual environment and then you can run these things. Okay, so let me run this code first. Python ML flow, then ML without ML for the py. So let it run. It's running in my laptop now. So yeah, as you can see, it's showing you the dataset as well as showing you the mean, absolute error, and R2 score. Okay. So this is the very basic code that we have here. Now, so first of all, I want to show you that how we can do tracking. We will do some very basic way of tracking using MLflow to get you started. That how it works, right? So first of all, what you need to do? Let me just do some CLS to clear it out. Now, first you need to install MLflow, right? Now for installing MLflow, you need to write a command called pip install MLflow. Okay, this is the command that you need to write to install your MLflow in your environment. Okay, very simple. Okay, see, anyway, it's already there in my laptop, so it will get installed automatically. Okay, now let's create a new py file where we will write some code. Okay, so let's create like ml with mlflow.py. Okay, so first of all, see, this thing will be same as it is imports. Okay, these imports will be same. Now what we need to import new thing, that is we need to import MLflow. We need to import MLflow. Okay, and also need to import MLflow MLflow.scalar. Okay, So we need to import these two things, new things, MLflow and MLflow.sklearn. Okay, it's ready, right? Now we will read the dataset as it is. This is the load dataset. Simple, same code. We are loading the dataset. I will toggle the word trap. Yeah. So I am loading the dataset here, and things will be same till this point. Like same. I'll copy from here. I'll keep it till here. Yeah. Till this it will be same. Okay. So I'm copying and pasting it here. Okay. So I have the scale dataset, right? Now one thing we need to do now. See, there are two things that I need to explain to you. That is one experiment and another one is run in MLflow. So experiment means, see, inside one experiment there can be multiple runs. Okay. See, in your case experiment is this code. Okay. I am experimenting on this dataset. I am experimenting on this dataset, and runs are under experiments, right? And what kind of run we are doing? Run is this one, this random forest. Okay, because we are running for different parameters to get a optimal accuracy score, get a minimum error, right? That's our goal, right? So that's the goal. So that means for this data set, for this data, for this experiment, we are doing multiple runs. Multiple runs in the sense we are running this model multiple times to get our expected output, expected accuracy score or expected loss, right? So that's our goal. That means first we need to create an experiment. We need to create an experiment, right? Because once we start creating an experiment, after that only we'll perform our runs, right? So let's create some experiment first. Now to create the experiment, let me just comment create experiment. Okay. So you can do MLflow dot set experiment. Okay. Set experiment. And in the set experiment, but I'm passing the experiment name equal to exp1. Okay, this is the experiment name. So we have done MLflow the set experiment. We have given our experiment name, right? So now what you need to do, so our experiment setting is done now. Now what you need to do, we need to perform our runs, right? Under this experiment we need to perform our multiple runs, right? Runs in the sense this is running this model on different parameters, right? So for that we need to write something. Let me first comment properly. Train model, and what you need to do that with MLflow dot start run. Then we need to pass our experiment ID. Inside the start run we need to pass our experiment ID. Okay. So if I pass the experiment ID, how do we get the experiment ID? Let me just show you how you can get it. This is the experiment, right? If you control V, if you do, then if you do dot experiment ID, yeah. So now with MLflow start run, we are running our running, okay, under this experiment. So we need to pass our experiment ID. So now this is the experiment that I created, and now I'm telling that you take the experiment ID from this one. Okay. So once I'll have the experiment ID, then we'll do what we do. We pass some variables, like see, in this random forest regressor we have used two parameters, n estimators and random state. So let's copy these values as of now. Okay, and just paste these values. We have these two values, right? Then how do we do? We call this, we just copy paste the whole code. Okay, copy paste this whole code, and then we do paste. Okay, and just let me just do this way. Okay, as I forgot to call this one, let me just copy this one also and paste it out here. Okay, so it's done, right? Now not here, sorry, I have to paste it. Yes, right? Now I'll pass this n estimators in our case here, and passing the random state here, right? Now we are fitting that, we are doing the prediction, we are calculating the mean absolute error and R2 score. So these things are ready. Now under this experiment, I am performing this many runs, right? Now runs will happen like I will run this code every time, and every time some run will happen, correct? See this, if there is no experiment available in the MLflow with the same name exp1, then it will create a new experiment, and if that is there, it will keep on appending all the runs under this experiment 1. Okay, right now I am doing set experiment and I am doing it for the very first time. That means there is no experiment called xp1. That means it will create an experiment and then it will keep on appending this all runs under this experiment. That's the behavior that we will see. Okay, now we need to log few things, right? We need to track, right? That's what our main motto, tracking basics. We are tracking our model. Okay, we are tracking our model performance based on its parameters, right? Under this experiment called exp1. So how do we track all these parameters and all these metrics? So for that there is some method called MLflow dot log param, same like we did for DVC, if you can recall. Okay, same parameter, same method name. See, it is suggesting me, my tab none is suggesting me everything automatically. But yeah, let me show you. MLflow.log param, we are passing anything you can pass, n estimators, anything you can pass here, any name you can pass. Okay, that is convenient to you. But the best thing is to pass the same name, because tomorrow if you want to see what all parameters you have passed, the actual name of the parameters if you pass, it's very easy for you to understand. Okay, for your after some days if you are checking the same parameters again, right? So this is your MLflow log parameters. I'm logging these parameters, I'm logging this random state also, and I'm logging metric. In our case, MAE is the metric and log metric is R2 score. So we are logging all of them. Okay, and we will log our model also. Okay, what we are doing, we are telling that okay, MLflow.sklearn dot log model, because our model is from scikit-learn, right? We are calling it from scikit-learn. That is why we have MLflow.sklearn.log model. We want to log our model, and the logging folder will be my model. Okay, so this is the folder name that we are passing here for logging our model. So it looks like our code is ready. Let's now run this code first. Python MLflow, then ML with MLflow.py. If I run this code, we got some error. Okay, let me just pass this way. Okay, and let me do CLS, and let me just run this code. I'll let it run. As you can see, it ran successfully, and it's showing, see, experiment with name exp1 does not exist, creating a new experiment. As I've told you, if there is no experiment named with exp1, it will create a new experiment. And it's giving some warning that MLflow model logged without a signature and input example. Please set a input example parameters when logging the model to auto infer the model signature. This thing we will do later, model signature and all that we will do later. But as of now, I just wanted to show you how we can do a very basic way of tracking using MLflow. As you can see right now, something has created here, right? ML runs. There's a folder is created. Okay, and this is the experiment. This is the experiment ID that is created by MLflow, and the same name they have used in the folder part also. If I click on this one, you can see some meta.yml. If I click on this, you can see. If I do this, first of all, the artifact location, the location of this one, this folder, where it is storing all the artifacts, when it is created, what is the experiment ID, when it was last updated, and what is the life cycle, and what is the name of the experiment. This all metadata stored here. Now, and see, this is the experiment ID. Now under this experiment ID, there is another folder called this one. So this is the runs folder. It contains the information of the run. Now, as I've told you, under the each experiment, you will have multiple runs. Same way, the folder structure is also the same. This is the your experiment ID, and this is the run ID. And same way, they have created a folder. Okay, and if I go inside that, you can see artifacts. Artificial just Conda YML model, ML model, model pickle file, everything these guys have logged here. See, this is the Conda. That means if you want to do installation using Anaconda, these all dependencies you need to install to reproduce this same pipeline or reproduce the same output. You need to use this many environment for your Conda. Now this is the ML model metadata. Okay, this is the model file that is stored already, that I logged, right? So that is stored here inside my model folder. Hope you can recall, I gave the name my model, right? And so for storing the model, it has created a folder called my model. That is a Python env YML. If you want to do on Python, Python environment, then what all things you need to install. It has given everything. Then the requirements or txt, what all installations you need to do, that also provided by MLflow. Right? That's really easy for you to reproduce the same thing again. Okay. Now let's close it and let's come inside metrics. You can see these metric values, right? Add to score. So these all metrics are stored here. Then parameters, n estimated random state. See, these also values are also stored here. Then the tags. In our case, there's no tags we have provided. So let's not focus on this one. Let's come in this meta.yml. You can see this is the metadata of the run. Now, but one thing, right? These things you can see here. These things you can see here. But you cannot see these things, like by seeing this way you won't understand anything, right? How so? We need to have some way to visualize it properly, and that is why MLflow has provided some UI that you can use to get it done. Okay, so this MLflow UI will take reference from these folders only to show you something in a proper visual format, right? So let me clear this thing out. Let me run one command called MLflow UI. Okay, so this is the command that is used to see the every experiment, everything in a proper UI format. Let me just copy this one. Let me just close all this and let me just paste it here. See, things came, right? This is the UI of MLflow that is running in my localhost right now. Now, as you can see, the two experiments, one is default and another one is exp1. So by default, MLflow creates an experiment, but in our case we have given a name, right? That is why there's no runs under this experiment, right? But if I check on this one, can you see there's one experiment? Sorry, there's one run that is performed 4 minutes ago. If I click on this one, you should be able to see the status, the run ID, the duration, right? As well as you can see this, what kind of model we have logged, these things are there. If I click on this model metrics, you can see the mean absolute error 4.69. You can see the R2 score 0.85, right? If you click on system metrics, then no system metrics. This, if it traces, then nothing traces as of now. Artifacts. Can you see that my model that I created, right? It contains all the model information, requirement txt, pickle files, everything, right? So these all things we can see. If we come below, right, in the under the overview section, you can see the registered models, right? You can see the registered models, parameters, n estimators, random state, right? As you can see, these metrics also that I have showed you already. So these all are getting logged here, correct? Now let's do something interesting. Let's stop this one as of now. Let's run this flow, this ML code again with some other values. Let's say we give random state of 56. Sorry, n estimate of 56, and let's rerun the pipeline again. Okay, let's rerun again. Rerun again. Now again I will learn MLflow UI. Okay, I'll again run MLflow UI. is running now. If I go back to here and if I come under the exp1, can you see that two experiments are there now? No, sorry, not experiment, runs. Can you see two runs are there under this experiment 1 now? That I told you already, right? So there are two runs under this experiment, correct? So if I click on this one, okay, n estimators, random share, mean absolute error, R2 score, these all things are here. Now another cool thing, if I select these two runs now and if I click on this compare, you can see now we can compare our using some plots, scatter plot, box plot, contour plot. We can compare our experiments, compare our runs also under one experiment. If you see, if I click on the scatter plot, in the x-axis I kept as an estimators, in the y-axis I kept as a this metric mean absolute error. So this way we can easily visualize it and we can understand that how our model is performing in different parameters, right? But right now it's like not understandable, right? Very true, it's not understandable anything. But just I wanted to show you that what all things are possible using MLflow. In the next videos we will more deep dive about these things, but just I wanted to show you these features that are there in MLflow. Okay, so I hope you guys have understood this tracking basic using MLflow. So in the next video we will continue from this part. So thank you for watching this video.